today I would like to give the sneak peek of our R16 Studio. To begin with, I would like to remind ourselves again about the studio. So basically in R15, the concept is we integrate the pre and post processors into one single platform. So the users can enjoy the benefits such as less click or efficient workflow, and also the special feature in Studio only. We call it multi-run comparison with the sync tools like sync angle, result, and range. And also we adopt the ribbon style or tree-style structure in our UI. So it will be very familiar for the users that has a CAD operation background in before. So now let's take a look at our video for the demonstration. Okay, so for the video, I would like to break it down into 3 sections. First is about the project operation. So what will be our new interface and so on. So yeah, this is the case that I picked from our talent award case from TomTom. So as you can see in this case, we use like a one-shot injection molding, and the background for this case is because in this ball socket we have like a thickness, so we will encounter problem like a sink mark, and also for this part they demand to have a cosmetic surface. So like wet line, we must eliminate the wet line. So yeah, basically this is the interface for the studio. So on the top side we have a ribbon style menu. So we have home, and then we have like model, yeah, like the pre-process to prepare the gate, cooling channel, and so on. And then we have also like the menu about the mesh to create a e-design or BLM mesh, and also some tools, and also the result menu that we will talk about it later, and also display, we will talk about it later as well, and the utility. So basically on the top, that one is a ribbon menu, and on this side we have like a tree-style structure. So basically this is the project tree, and in here we have a model tree. So as you can see, that is very convenient for the users to show or hide certain objects. So for example, if I want to show the mold base, the cooling channel, or hide it, or so on, it's very easy to control it in this model tree. And then we also have like the defect tree. So we can see that the surface mesh defects or the solid mesh defects remain for the mesh. And besides the defect tree, we also have a run information list. So this is the new things in Studio. We have the run information list, so users can check again like the model details, the material, or the process condition. And the last in the model tree, we have like a geometry and also the material which belongs to it. So yeah, this is the interface for this R16 Studio. And for the operation, we also have the new tools here. So as you can see, we have like some tools like edit remarks. So in case you want to give a certain name for a certain run, for example, like here we have like original, revision 1, and revision 2, something like that. That one will belongs to edit remark. And we also have like export runs. So like for example, in here, if in case you want to export, for example, run 1 to a new project, you can also freely to do that, and you can give the name for that one too, a specific name. So for edit remark, export is very convenient. And inside we also have like a copy run, or like a clear results, or also the delete runs. So for like the copy run like this, for example, we can also copy like input data only, or maybe full run data in case you already have the results. And also maybe you can customize which results that you want to copy. So this one can give the benefits for the users in case they want to copy several runs, but only change certain inputs only. But the rest of the inputs are kept the same. So it will be convenient for the users to do the operation. So yeah, write input data, full run data, customize. Users can pick anything they want. And the next one, the next section is about the MCM analysis. We know that in the regular injection molding, one of the common case is about MCM, multi-component molding. So we have like a part or part insert, something like that. So yeah, basically like in this case, like I introduced before, like we have the problem about the ball socket. So we have like a sink mark because it's thickness. So like in the studio, we can also display the thickness distribution like this. So as you can see, like the most of the thickest region will be on the ball socket, which will induce like the sink mark problem. So that's why we will try to do like a 2K injection molding for this case. And I would like to compare using our studio interface like this, side by side on the left and right side. So yeah, this is also the special feature in the studio that you can compare the two different runs side by side, left and right, something like that, in one platform. So user will be very convenient to control everything and to show everything in one platform. So like here on the left, on the right side, you can see that that one is a 2K injection molding. So we try to have the first shot is on the beam and the second shot on the ball socket. So our studio can now support also this 2K injection molding or MCM technology. So, and in here, I also would like to see that from here, we can see that why we do need to change to the 2K injection molding, because now the thickness for the ball socket will be reduced by using this kind of technology, the 2K injection molding. So this one will help the designer to solve their Sigma problem. So yeah, we can hide and show the part insert, something like that in the model tree. And also this one, we can check the material. So basically users can do it very easily, like set the material for the part and set the material for the part insert very conveniently from our UI. So yeah. And on the left side, I try to show you also like, for example, I want to open run 2, which is the first shot for the revision 1. So you can have the feeling like what will be about this 2K injection molding. So basically on the left side, as you can see, that one is the first shot, so the beam. And on the right side is the second shot, the ball socket. So yeah, this is our MCM analysis for the studio. And the special setting that we have usually in our MCM analysis, we have in the computation parameter. In here, we have a MCM tab. And in here, as you can see, we have what we call as a link with the previous shot. So it means your second shot will have the link with the first shot. So it will carries like the temperature result from the first shot. So it will influence the result for our second shot, which means that like for example, in the overmolding case. And the last section for the demonstration video is about the result inspection. So yeah, basically we will see like several things, the new stuffs in R16 Studio that we can use. So for example, the first one is display maximum and minimum. So when you select one particular result, like for example, in this UI is melt front time, you can check the maximum and minimum value will show up. And in case, for example, you also turn off like run or something like that, this maximum and minimum value will automatically modify itself. So it's very convenient for the users. And in case they want to hide it, users can also hide it in the display setting. So that's our new feature, display maximum and minimum. And the next thing is usually, for example, like the temperature, if we also want to check the maximum, the red color, the highest temperature, something like that. So we can use the clip, and we can also see the distribution. What is the temperature distribution for this case? So for example, we have the new feature now in R16, we call it result advisor. So users can double click on the result, and then it will show this statistic or the distribution of the temperature. So it's very convenient to use the studio to check or investigate the result. And the third new things in the result inspection, in here we have the tool, we call it probe. If you notice that in the project we have what we call as the measure node, but in the R16 Studio we have probe. As you can see, we can place the probe anywhere. It doesn't necessarily to be at the mesh point or mesh node, but it can be like outside of it. As you can see, when I pick it outside of the mesh node, but yeah, even we pick it outside there, we can still check the result. So in here, our probe can do the intermediate value calculation. So it will do the calculation in the intermediate mesh nodes. So from here, yeah, we can double check again that the probe is not on the mesh node, but it can still show you the result. And in case the users want to hide it, you can also set it in the display setting. So that's the probe. So, and also we can check it in the model tree in case user want to hide the probe or show it. Okay, so that's the new things. And now I also want to compare again about the original design, run 1, and also on the left side, I try to show the revised design, run 3, which is the second shot, the 2K injection molding for this case. So yeah, like we can use the compare tool on the top side. You see the tool, and then we can compare. On the left is the run 1, and on the right is run 3. And then we can also sync the angle and also sync the result. So as you can see now, it shows the same result, map from time for both left and right side. So as you can see now, for the original design and also the second design, we can see the map from behavior. So they have a different map from behavior because they have the different object or the part. And for example, next, I also want to investigate the volumetric shrinkage. So yeah, basically we just need to select the volumetric shrinkage for one run, and it will automatically change the other run to show also the volumetric shrinkage, because we have the tool what we call as the sync result. And then I just click the sync range, which means that the range on the left side will also be the same as the range on the right side. So it will really help the users to judge which design that has the higher shrinkage. So for example, on this side, we can see that run 1, or the original design without 2K injection molding, it has the higher shrinkage. So we can say that the revised design 1 really can solve or improve the problem for the sync mark for the original design. And now I try to open the sync mark displacement. As you can see here as well, like the sync mark on the run 1 is higher based on the color distribution and also the value. So that's how we can use the Moldex3D Studio to do the comparison using sync angle, sync result, and also sync range. And this is the fourth new function in Studio. We call it measure distance. So basically, users just need to point 2 points or anywhere user will pick or select, and it will help the users to do the measurement. The measurement for what? And the measurement for these 4 things. So model size, and then after deformation, what will be the size and the difference, and then what will be the linear shrinkage of that 2 points. So the Studio will help the users to plot this table, and it will help the users to know the linear shrinkage on those 2 points. Okay, and next, because we already know that based on the revised design, we will have improvement in the sync mark. So now we have the other concern is about the wet line, the cosmetic surface. So from here we can see that our revised design still has the problem about the wet line on the socket ball. So that's why we need to do the revised design too, because we try to also improve this wet line or eliminate this wet line. So in this display, I try to show you on the left side our revision design too. So basically, we change the gate that will change also the map from behavior. So we will take a look soon. So like here on the left side, you can see that the map from like from the bottom to the up side of the socket uniformly. So it will eliminate the wet line. And we can double check and confirm it with our wet line result. So as you can see in here, like on the left side, we don't have any wet line on the socket ball, but on the right side, which is the revised design 1, we still have that problem. So basically, it's very easy for the users to compare and to know the improvement from different revision design. Okay, and this is the last new feature that I will demonstrate in the video. We call it the historic curve result. So in here, I try to compare like the run 3, the second shot of the revised design 1, and also run 5, the revised design 2. So I try to plot the sensor node result, the temperature result for the sensor node. So basically, this is the new thing in the Studio. And in project before, we don't have any ability to compare sensor node result from 2 different runs. But in the Studio, we can do that. So this is the special feature only in the Studio. So it will be very convenient for the users to understand like what will be the sensor node result. Like for example, in this side is the temperature, how the temperature will change using the revised design 1 and revised design 2 at certain sensor node location. So yeah, that's all for the demonstration.